All right, so let's start the session. I'm going to be talking about the standard for the system architecture on the Arm-based servers and PCs. So the agenda today, we're going to be talking about the system architecture. I'll go an overview, and then we talk about how we come up with these system standards, what these specifications are, how do we make sure the compliances are there, and there's also a little bit about the server manageability and system manageability as well before call to action. I have quite a few of the slides, but I'm going to be going through very quickly because some of the server related specs, I think I've presented that in the past Lenovo Connect before. So I'm going to be, giving you the recap, but I'm not going to be diving too deep into those. So in terms of the ARM system architecture, here's a diagram that probably could help everybody understand what these specifications are and how we connect it into various different programs. Sometimes I got these questions like, how are these specs connected? So if you come to the ARM ecosystem, right, you're very familiar with the left-hand side with ARM reference menu for the instruction set and many of the related specifications like interrupt controller, SMMUs, and such. So that's the CPU-related architecture side. What I'm going to be talking about is the right-hand side, where we define a bunch of hardware and firmware standards beyond just the CPU side. It certainly also refers to a lot of the CPU architecture requirements, but it's not only centered on the CPU side. It also covers how you build the entire system. And then we also have the compliance programs on the top that utilizes these specifications and help you to figure out whether your system is designed to be compliant. And we have made some changes to that compliance program. I'll talk about those later on. So this gives you, if you leave with this session, if you can remember this slide or refer back to this one all the time, you can have a very good picture of what we are trying to do. But I'm going to be dealing with a little bit of details on how these specifications are created and what they are about. And a lot of you are creating also devices or systems for different segments. And sometimes you also have the question of how these specs are fitting into different markets, right? There were a lot of confusions when we created some initial programs before. We have a struggle of how we, fit these specifications into different markets. So this also gives you a per segment kind of understanding of what each of the specifications are about. So basically the CPU side of the architecture applies everywhere, right? This is Arm ecosystem. And then depending on how you build the system, which market you go through, you need to have some foundation of hardware, and that's what the BSA is about. But if you use device tree to boot Linux, you don't necessarily have to have these hardware requirements because device tree gives you the ability to describe the different hardware, but that also gives you the task of trying to make sure your SoC support is upstreamed. But if you use the BSA across the board, then you're enabling the abstraction so that the new and old OSes can be supported on new and old hardware as well, right? So on the server and PC and also Windows IoT, you want to have the basic BSA hardware so that you can put the abstracted firmware interfaces like ACPI on top. So then you can support these OSes on the platforms. We also have the VBSA that's relatively new, and I'm going to be talking about that later on. This is about the virtual environment for running hypervisors. Of course, ARM also has the confidential compute and chiplets standards, architecture as well. So those are not necessarily related to the OS enablement, but those are also very important. All right, so to come up with these standards, it's not just ARM, or my group kind of looking at writing down requirements all by ourselves, right? That's not possible. What we have is this System Architecture Advisory Committee where many companies, from silicon vendors, OS vendors, IP providers, OEM, ODMs, firmware vendors, hyperscalers, everybody work together to contribute. And we try to use the standards approach, leveraging what we can from the industry to maintain the compatibility and consistency, right? And then, because this is a relatively huge task, so different people may have different expertise. So we actually created a number of sub-teams to work on those. And we have a very well-defined flow for submitting the request for the changes to the specs and getting the, this architecture forum to approve the changes, right? It's not like I or somebody from ARM just arbitrarily make changes to the specs. Everything has to go through a review process and approval. Sometimes we make mistakes. We become too aggressive or not aggressive enough, right? So we learn from that, and we modify the specs accordingly with the ecosystem approval. So specific to the specifications, so as I mentioned earlier, we have a base system architecture which tries to establish the basic hardware requirements when you build the system up. And of course, as I mentioned earlier, it would be nice if you're building a silicon SoC based on this architecture, then you can do whatever you want to support the OSes, right? You can either use the device tree or you can use the ACPI. But if you don't follow this BSA, then you can't use the ACPI, and you wouldn't be able to run the OSes that requires ACPI. So BSA is very important as a foundation. And then the BBR, the base boot requirement, this is basically defining the high-level firmware interfaces into the operating systems. We also define different recipes. We understand that there could be many different ways of booting the operating systems. Officially, now we support two mechanisms. One is using the UEFI ACPI SM BIOS, which is called SBBR. And S doesn't really mean servers, right? I mean, if you build PCs or Windows IoT, you want to use SBBR as well. And then you can also use UEFI and device tree for the EBBR for embedded systems. The document still contains the Linux boot recipe, but we're not looking at that area a lot these days. I think there is an attempt from Google that we're looking at putting on the UEFI payload on top of Linux boot. And once that's done, from the interface level, you can't really differentiate between SBBR or LBBR because they all support the UEFI, ACPI, and SM BIOS interfaces. From our side, we don't really care what code bases you use as long as these interfaces are delivered to the operating systems. I mentioned earlier about the VBSR. We looked at the the hyperscalers cloud instances. We looked at like the parallel desktop or VMware Fusion, right? All these virtual machines, they all presented to the OS some kind of a faked virtualized hardware. So this VBSA is an attempt to write down those requirements, how you want to, pretend these kind of hardware are in existence to the operating systems. So we have published the spec earlier this year. And I'm not going to get into too much detail here, but you can always refer back to the content in these BSA roadmap, right? So we already published 1.1. We're working on 1.2, and eventually we want to work on 2.0. I think one of the area that was missed earlier in the 1.0x version is the requirement for FEAT LSE. This is required by Windows 11, so we want to include that in the future versions of the spec. BBR, we have published one last year. I'm in the middle of trying to close the next version. I'm waiting for the ACPI 6.6 to be published. They run into a bit of a problem right now, but I hope in the next few weeks it will be published. And so the BBR 2.2 is going to, based on everything, very recent and ACPI 6.6 as well. As you can see, it mentions the PC BSA. I'm going to be talking about that later on. So we're trying to not only cover the server space now, but also the PC space. And then the intent is to maybe update the spec every year because we probably have more PC-related requirements coming in. This is just a visual diagram of what these different recipes are. So the major ones, as I mentioned, is SBBR, which is for servers, PCs, and Windows IoT. So this is UEFI, ACPI, and SMBIOS, plus a few of the ARM-specific interfaces like PSCI, SMC, right? And then you also have the EBBR recipe where I mentioned UEFI device tree with the SMC and PSCI as well. The BBR spec also refers to a bunch of specs that ARM produces for the firmware ABIs. So this is like the SMC, FFA. So I'm just putting that in one slide so that you can always refer back and check these different specifications. One thing that I want to point out is this particular one, we produced a document that basically says for PCI ECAM, the configuration space, there could be a firmware interface to abstract because we saw a lot of the IoT devices not providing the hardware mechanisms for ECAM. But unfortunately, Windows and Linux, they don't want to adopt this. So, the document is still there, but there's no taker. So the intention from these OSVs are still wanting the hardware to provide the full ECAM as defined by the PCIe spec, which is the hardest thing to do in the server and PC and IoT devices that we have been doing in the past. The IP from the silicon providers may claim to be compliant, in terms of the root port and root complexes. But when you integrate with your CPU IP, the integration has a lot of issues. You have to find the right configurations for that to happen. Otherwise, the ECAM is not going to show up or show up in a kind of a fragmented way that's not complete. So the OS cannot use them. Right, we've seen that on most of the non-server SoCs. There are also a bunch of ACPI specs that ARM produces to cover some of the features. as well. So I'm not going to go through them. You have the collection here you can refer back to. This is basically for Arm to describe these devices through ACPI. I mentioned the VBSA. We published the VBSA 1.0. We're looking at the future versions, but there are not a whole lot of new requirements yet. So we don't know when the next version is going to be. We hope the 1.0 has captured most of the needs. And then there's certainly also, for servers, we have the SBSA, right? The server-based system architecture. I mentioned that we also created now the PC BSA for the PC side. BBSR is for covering the security side of things like secure boot or firmware update, TPM support. And that spec is kind of in the maintenance mode. We think that we may be eventually integrating or merging that into the BBR because most of the requirements are firmware related. So I'm not going to, again, talk about the SBSA roadmap in detail. We have the 7.2 published. We are working on publishing 8.0. We were moving very fast in terms of the new levels and such, but we now have two guidelines on the right-hand side. We're basically saying we want to make sure the OSV will require these new features in the relevant time frame before we declare a new version of the spec. And also, we want to make sure the silicon vendors actually have the commitment to support the new features in the relevant time frame, right? We don't want to go too fast. We can declare a version 20, but if most of the SoCs are still at 6, then there's going to be a huge gap. So far, we have seen silicon SoCs at version 6 or level 6, right? So 7, we have seen some development, or even 8, but the existing SoCs, most of them are still at level 4, some at level 6, a couple of them. So now PC BSA, this is new effort. This is not yet in the System Architecture Advisory Committee. This is currently published by Arm. We're trying to kickstart an effort to basically do a very similar thing as the SBSA. We actually, as a matter of fact, we're trying to look at what's in all these levels in SBSA and try to see if any of those requirements are relevant to PCs. So we're kind of doing that exercise. We've done that for the initial version, but in addition to these, so the first version is basically focused on the SBSA levels 3 and 4 and see how those mapped into the PC market or not, right? And then now we are looking at the level 5s and up in SBSA, and then look at whether they apply here. But I think, as you know, if you're building a laptop, you have to do thermal and power management, and you also have embedded controllers, a lot of interesting new areas that you have to work on. So those are the areas that we're going to be looking into in the future to make sure all these things are supported in a standard manner. You have the existing laptops in the market that are very specially designed, right? That not quite using all the standards mechanisms. So we're trying to establish that foundation as well for the PC market. In terms of compliance programs, if we only have a spec and if we don't have a way to check the compliance, the specs are useless, right? So we have teams developing the compliance test suite. We're hoping that the partners eventually will include the use of these compliance tests in their certification efforts. We're talking to a few of these vendors, OS vendors as well. Pre-silicon, I think in the keynote earlier today, Pedro was talking about how they use pre-silicon simulations in Windows development, but we also have the pre-silicon program for the SoC development. I think he mentioned that nowadays people want to tape out the silicon once, not many steps, right? So we're trying to do that. Like I mentioned earlier, the PCIe integration is the hardest, and we want the pre-silicon program to help the silicon SoC designers to make sure before they tape out, their solutions are actually going to be compliant. And if some of you may be very familiar with System Ready, which is a program that I have talked about at Lenera Connect for quite a few years. So we have moved last year from the certification regime to a compliance regime. So we are not going to issue certifications after June 30th. We're kind of cleaning the pipe right now to make sure those of the vendors who are working with us before can complete their certifications. The difference is that certifications, the vendors would have to send the hardware to us or give us the remote control. We do the test, we review the test results, and then we issue the certificate, which is very time consuming. But it's really good initially because this is a new area that people entered into. Now we think it's mature enough that we want to move to a self-declared compliance. We're still going to help with the partners on these kind of pathfinding projects. If you have a new SoC and if you have a reference board that you want to work with us, we can try to see if we can accommodate that. And we're also interested in finding out whether the new SoC is actually compliant. But then we are letting the partners to declare compliances themselves, for the various SKUs and all that. The program, of course, enjoyed a lot of support. As you can see, major CSPs, from the cloud side, all participated. Major silicon vendors, software OS vendors, and hardware vendors as well. EDA, firmware, all kinds of people are very supportive. The last topic I want to cover is the system manageability. On the server side, we also define this spec called the server-based manageability requirement document. We work, utilizing the industry standard Redfish, DMTF, IPMI, right? We created the requirements, and we work with a lot of the vendors to make sure you can have a standard way to manage your server fleet. In fact, nowadays, when we talk to the cloud service providers, the first question is how you manage these servers, right? So I'm not going to get into too much detail. Basically, SBMR is there to define the interfaces between the BMC, the management controller, with your SoC, with the I/O card, with the platform elements, using Redfish, using IPMI, and PLDM, which is a DMTF standard for how you use the protocols to communicate between these entities. We also use the leveled approach because initially people design their own ways of management. Later on, they want to move collectively to IPMI and then Redfish. So we gradually provide the levels for people to move to. Again, I'm not going to delve into the details of the roadmap. 2.1 is already published. We're working on 3.0. We also have a test suite, ACS. We develop with a lot of the vendors also. I mentioned the PC side. So commercial laptops, the business laptops that you have in the corporation may need to have these kind of system manageability functions as well for remote management so the IT can control your platform. And we may need to develop some of the out-of-band standards which is not there today. In band, you typically use Microsoft Intune. Out of band, right now there's no standard. Intel has their way, AMD has another way, right? vPro or AMD Pro. So it's not quite standardized. So we have these questions that we need to figure out whether we need to standardize or not. So call to action, join the System Architecture Advisory Committee if you would like to participate in the spec development. We actually have a face-to-face in the US at the Google campus next month. And then you can also review the PC BSA. It's all public. You can search arm.com, PC BSA. It's all there. The QR code I have in the slides also point you there. You can use the page 10 in that spec to give us feedback. So that's kind of the current mechanism. For the other specs, you can join the System ArchAC. You can propose changes and everything very readily. And then think about what are other areas we want to collaborate on the standards development. So I'm a little bit over time. I don't think we have time for questions, but I'm going to be around until Saturday. So just find me. We can chat offline.